Hello, my name is Toro, and today I'll be presenting my key activity, the falling stage. Hope you enjoy it. Well, to understand completely the topic, first we need to know a clear definition of free fall and its characteristics. In Newtonian physics, free fall is any motion of a body where gravity is the only force acting upon it. In the context of general relativity, where gravitation is reduced to a space-time curvature, a body in free fall has no force acting at all. For example, when we are standing on the ground, the force Earth's gravity pulls our body towards the ground. However, because our feet are in physical contact with the ground, there is also a normal force pushing upwards to our feet. It is through this contact force on our feet we are able to perceive the force of gravity as weight. If the ground beneath our feet were to disappear, gravity will be nonetheless be acting upon us, but we will be unable to sense it. This inability to feel gravity will make us feel weighted. The purpose of this experiment is in the laboratory is to measure the acceleration of a falling object, assuming that the only force acting upon it is the gravitational force. Some goals behind it also is to determine the effect of mass on the motion of a falling object. Number two, to review relationship between position, velocity, and acceleration. And the number three goal, to determine whether the acceleration experienced by a falling object is constant, and if it is so, to calculate the magnitude of the acceleration. Some story behind it, according to Glenn's Research Center, is that the weight is the only force acting of the object. Also, Newton's second law of mo, second law is motion of the object. Mass of the object does not affect the motion. Shape of the object does not affect the motion, and according to Galileo, all objects fall at the same rate in a vacuum. In the right, we have an Islamic philosopher and physician that in the 12th century gave an explanation for the gravitational acceleration of falling bodies. He proposed an explanation of the acceleration bodies by the accumulation of successive increments of power with successive increments of velocity. Okay. In the methodology section, we have the following variables: independent variable being the height, dependent being the time, and control variable objects with different masses. Uh, Materials and process. In this section, we use 7 materials for objects with a variety of masses between 400 grams to 1.7 kilograms, a chronometer, and a weight scale. In the process of this experiment, we tested the relation between the dependent variable, which in this case is time, and the dependent variable, which in this case is height. We took objects with different masses and dropped them from the same height in order to fall to the ground. With that being said, the experiment was made with a variety of masses between 400 grams to 1.7 kilograms. If each of these objects were dropped from the same height and the time was counted by a chronometer. After this, after this being tested, the data was compared and the results were discussed. For example, we can see a relationship between, well, weight and the time. When the weight is lighter, like you can see here, it takes even less time. And and according to, well, to the increase of the weight of the object, also the time, well, it gets bigger, like you can see here in the table. Well, next. If we draw a conclusion, we can suppose that if another object of the same size but with a greater mass was dropped instead, how would the speed values will change? The answer is that we need speed values would not change. We have this here also. Well, some conclusion that we can give is that this experiment proved that the gravitational field strength is constant in all cases of free fall. The height, the height from which an object is dropped and the time of the fall does not affect its acceleration. By comparing the obtained acceleration values with the constant value, we are able to count experimental errors. We can found them. We can therefore conclude that the acceleration due to gravity is 9.8 meters by square seconds. Well, um, these are my references, and thank you so much. I hope you enjoyed. I hope it was a clear explanation. Sorry for the English level, and this was all my presentation. Thank you very much.